that's me. So I'm Frédéric. I'm VP Technology and Engineering in Amenitiz. So if you don't know Amenitiz, I'm not going to talk for 15 minutes about Amenitiz, but just a short story. But Amenitiz is a hyperscaling startup in hospitality industry. I've been working for 2 years in this company, but I've been working in travel industry in general for the past 15 years. And my journey with technology in general is how to use technology in order to support the business and to create opportunities, innovation, and to bring a better product for our customers. I will try to explain to you through this journey on the AI. So I hope that you are going to discover or to learn how you can use AI in the day-to-day in order to increase productivity or in order to include it into the product, and you will see that that's not so complicated and it does not require, and if you're an engineer, maybe you are not going to love what I'm going to say as a VP engineering, it's not that complicated and it doesn't cost that much to include AI. So when your team is going to say, hey, it's super complicated and they need 1 month to do AI in the product, maybe not. So I'm going with a short introduction to AI, then we are going to deep dive into LLM, large language model. Not sure, it's not going to be super technical. I will try to remain really high level so that you can really understand, so where do we stand in terms of innovation, in terms of AI, and you will see the opportunity that you can leverage thanks to AI. And then we are going to talk about exploration with what is multimodal. So what is multimodal and what can bring also multimodal with AI. Fine tuning in terms of large language model. One technique called retrieval augmented generation. So those are different ways to use different techniques to use AI in the product in general. And we are going to see also the vector embeddings and then Q&A. But if you want to stop at some point because it's not clear, just please raise the hand, don't be shy, and ask questions. So first of all, a little bit of introduction about AI. So for everyone to start with the same foot and with the same knowledge. What does artificial intelligence? There is 3 points. First, artificial intelligence has been introduced in order to mimic human intelligence and then converses in multiple languages. I'm pretty sure that you know about ChatGPT, OpenAI. I was curious about one survey I've read, which is about 64 workers in the world did not use yet one AI tool in their enterprise. So I hope that after this meetup, you are going to push in your company, well, to not be in the 64% of people in the world. Second, AI also helps to solve complex problems. We know that as a human, we are good for creativity. Machine learning in general has been good in order to solve complex problems. But AI right now is as good as human, not yet, but to solve complex problems, but also to be creative. And that's what the rise of AI and with ChatGPT, and also to predict traffic patterns in general. The third, which is about pattern recognition. AI is really good to recognize patterns. So if you want, for example, in terms of traffic, in terms of prediction, forecasting, AI is really, really good. In finance, for example, if you want to put your BP and try to understand is my BP is really good. And I'm working on this for 2024. And I'm trying to see my BP on 2022, my BP on 2023, what I plan to do, what I really realized. And then AI is really good to try to see some pattern and to help you then to predict the forecasting. But also in terms of automation of tasks. So there is a lot of, I don't know if you heard about AutoGPT, for example, which is one framework that is helping about automation, but automation of tasks, AI, not yet, I think that not yet everyone is using for it, but it's also really good for automation of tasks, and especially with this week, in the dev day at OpenAI. I don't know if you heard about this, but there is huge things that are coming from OpenAI, and on the coming weeks and months, I think you are going to see a lot of new tools, and thanks especially to the ChatGPT builder, that now everyone will be possible to build ChatGPT application. So they are going to have a huge store with application and with automation and operation. So let's come back to the future. Brief history and evolution of AI. It started in 1950s with Alan Turing, this person. And so this person who had in mind that one day he had a dream, one day that machine can be like acting as a human. And so in order to determine when this moment will come, then he created one test, so the Alan Turing test, which is a computer and a human interacting, and on the other side, so some people and trying to with the computers and interacting and trying to see so which one is the computer, which one is a machine, which one is a human, just to summarize and to make it simple. And so this test, so everyone is talking about AGI, which is so the moment where the generative artificial intelligence will be acting as a human. When this AI will pass the test, that will be the moment. People think that it will happen in 2024. It might happen in 2024, but then the Alan Turing test has been created for this purpose. In the 1980s, so it's the birth of learning machine. So machine learning, I'm pretty sure you heard about a lot of people thought at some point they wanted to be data scientists and to go to machine learning. I remember 10 or 15 years ago, every engineer wanted to jump into this because of the money, because of the salary, and also because it was super interesting. But yeah, right now, I think it's OpenAI or artificial intelligence in general can really do what data scientists and machine learning was doing at this moment. But in the 90s, so that was the beginning of learning machines. You can see, so 60 years after, so that's the beginning. So the 2010 is the beginning of really of the AI. So with the deep learning era, with enhanced image recognition. What does it mean? It means that for the first time, so we could use machine learning and artificial intelligence in order to do image recognition. So in order to use, for example, think about the Google CAPTCHA and trying to, I'm pretty sure that, yeah, some people I was working with, I remember the day we wanted to automate the Google reCAPTCHA because they were just blocking us to do some web scraping. That's not, I mean, it's not a good practice, but we needed to do this. And so, yeah, so in 2010, more or less, we are doing this. And then in 20s, pretty sure that you remember about this. So 1 year ago, or beginning of the year, more or less, so the emergence of GPT-3 and GPT-4. So this is now where we stand, so in terms of big language brands. So this is all the journey of artificial intelligence from the 50s, with Alan Turing started to have this dream, and then, yeah, 70 years after, so that's the year, and that's the moment, so where do we stand? And so this is where innovation is really starting to be worldwide used and known by everyone, and that's why you are in this room. So let's start. So what is the relevance in today's world? How this is useful? First, industry transformation. As you can see in this picture, boosting efficiency. Every company aims at some point to boost efficiency. And not only because of AI, because companies have to be efficient. That's the way to go for profitability at some point, is first to be efficient. So AI is really good right now to be used in industry transformation and then to boost efficiency, but also for us as humans. Simplifying software development. I don't know if you use in a company, in my team, I introduced, well, almost all of these tools. I'm investigating right now in DevGPT. I don't know if you know about this, but I can put you in contact with the founder of this company. It's really good. We tried GitHub Copilot, Codium for the end-to-end for the JavaScript tests, Poolside, which has been created and launched by the ex CTO of GitHub and Eizo from Athenian. So they just created this. Remember this name because I'm pretty sure that soon you will hear about this. And DevGPT that has been founded by Ash Lewis, and so they are moving to San Francisco. They raised some money recently. So all of these tools are really simplifying software development. We are trying these tools in my team. I don't know if you heard about this, but well, those are quite complementary. None of them is going to replace one, but they have different approach and different, I think different horizon in terms of supporting, helping, generating boilerplate of codes, or really, like for example, DevGPT, I was discussing with the founder this morning. They aim to analyze the Jira tickets, if you know about this. So they analyze the ticket, and if you have everything in the ticket, they are going to check the code, they are going to do the pull request, they are going to notify engineers, and they are going to ask, okay, if you want me, I can just deploy it. So DevGPT is doing this. But also AI nowadays can guide ethical choices, and specifically in clinical decision. So this is not BI, it's not as a human. And so ChatGPT is just acting as a brain, as a kid with a lot of knowledge, and not getting BIs. Not like us as a human. We are BIs about many things, about our feelings, about our story, about our past, about our dreams, and AI is not. So this can also be super helpful in clinical decision. Last, not the least, I introduced this also in Amenitiz, but enhancing customer interaction. And we are going to see all along this presentation, I would always try to take as an example a chatbot, because it's something that everyone can understand. So every single technique we are going to see, fine-tuning, retrieval augmented generation, about vector embeddings, whatever, I'm going to explain to you every time at the end with one example of a chatbot and how every single technique can bring a different chatbot and a different experience for the customers. So let's deep dive now into the large language model. So you heard about LLM. What does it mean? Large language model. What is this? What is a large language model? Well, it's a giant brand. It's just, and we'll see how important it is to understand how this is composed. It's a giant brand that has been trained with a lot of data. And that's why there is now this war between different companies, and Google is trying to beat Apple in terms of because they have all of the data. They have access to a lot of data. Data is key in AI. If you don't have any data, you are just a layer in the top of OpenAI, and so sooner or later these companies are going to die. But the ones that have the data, they are going to build these giant brands that you can specialize. And so a large language model, so a giant brand that understands and generates text like humans would do. That's all at the beginning. This has been trained by a ton of text. So gigabytes and gigabytes and gigabytes, and it costs millions of money in order to really train a huge model. So it's not something that every company aims to do, because it is really specific and we don't have the necessity to do it. And there is already a lot of models in the market. We are going to jump into some of them that can be really useful, and we can already use in the top of this and fine tune with external knowledge. So GPT-4 has been vast trained on diverse text data, for example. But not only text. Some LLMs, large language model, has been trained in order to create some images, to audio or video, speech, for example. So it depends. A large language model, so think about it, it's just a brain with some data inside, and that is specialized for something. And we are going to see after multimodal and how we can combine all of this in order to have, well, multiple giant brands that can bring even more knowledge. Yeah.
I remember reading somewhere that the architecture was like a network of different models. So instead of GPT 3.5, that was 175 billion parameters.
Yes.
GPT-4 architecture is actually like 6 different models.
Yeah, they started with Instruct GPT at the beginning, and then in order to, and then they specialized in order to develop GPT-3, GPT 3.5, 3.5 Turbo, 4, and recently this week they released GPT-4 with the context of 128,000 of tokens. And I'm going to explain why the billions of parameters are important and what it brings into the model in terms of creativity as well. So GPT-4. A chat buddy, meaningful and helpful. How many of you have already used OpenAI with GPT-4 in this room? Yeah, a lot. I do it every single day. So, how many of you do know what GPT means? Yeah, much less. So, the G is for generative. Generative, which is ability to generate new data that was not in the model. Okay? So GPT, the G is for this. So just its ability to generate new data that was not in the model. Hashtag creativity. P is for pre-trained, meaning that, well, it's a model, LLM, it has been trained with data. So that's the knowledge. So the G for the creativity, the P for the knowledge. And the T for the transformer, which is a machine learning architecture. It's been for a long time, for the 80s, 90s. So it's an architecture that helps computer to understand stories like a human do. So that's for the understanding. So that's the combination of the G, P, and T, which is about creativity, about knowledge, and about understanding. Okay? And you will see why this is important. GPT-4 is what, well, there is a lot of sources, but it's 1.76 trillions of parameters. And why size matters in this case? Why does it matter? Well, because of the learning capacity. Parameters, so the 1.76 trillions of parameters for one LLM is the learning capacity. Imagine a brain with neurons. There is 1.76 neurons into this brain. It's a big brain. So that's more or less, to simplify, what the parameters they mean. And the more they are, and the more they are creative. In terms of problem solving as well, more parameters help to tackle different kind of problems, like the more neuron in the brains, and well, the smarter normally people can be in terms of problem solving. But also in terms of memory storage. The more parameters mean store data knowledge, neurons store life experiences. So the more parameters there is, and that's why GPT-4 is one of the most creative LLM. Some are more factual, GPT is more creative because of 1.76 trillion parameters, but because also of the architecture of the GPT. Creativity, knowledge, and understanding. But there is a lot of other powerful models. I'm not going to deep dive into each of them, but just to make some difference. For example, BART, which is 500 billions of parameters, much less, 60% less, more or less, and is more factual. I know if you use BART from Google, I'm jumping from time to time between Claude, between BART, between GPT, between Perplexity, but Perplexity is more an application on top of this. They don't own their own model, but they provide all the models in one single application. And it uses an LLM Palm 2, which is a pathway language model 2, a different architecture, and is more factual. So if you don't want this creativity from GPT, that sometimes like, okay, GPT will always try to please you. Like, it doesn't know, but he will try to create some data because of the generative, and because of the knowledge and the understanding. So if you don't put some prompt saying, no, I don't want you to be creative. I want you to focus on giving me the data. If you don't have it, say, I don't know. It's not good for this. Yeah. Like some human. They don't say, I don't know. But Bard is pretty good at this. So Bard, if Bard doesn't have the information, we will not give any information. We say, I'm just AI. I don't know how to do this. And that's fine. DALL-E, the third version, is a picture wordsmith from OpenAI, and it's specialized to create images. I don't know if you use DALL-E, which is now accessible, so in ChatGPT, if you have a premium access. And I don't know if you know for the story, but DALL-E has been inspired at OpenAI between the artist Salvador Dali and then the Pixar Wall-E. So DALL-E is for this. So they chose the name because of Salvador Dali and because of Wall-E. So for the artist, and then because they believe in the story, I don't know if it's true, but on the story they were saying that they believe that the robot that is aiming to save the world and having some feeling, and plus the artist that was Salvador Dali. So that's why that's how they created So DALL-E. With 12 billion of parameters, much less because it's enough in order to create some images. And the last one from Anthropic, I don't know if you use, is in beta right now in United States. It's quite hard to use it, but you can use the beta version for free and plug it to Slack if you want to introduce another LLM in your Slack in your company. And has been designed to generate, so it's quite different. It has been designed to generate non-toxic, safe, and helpful output for users. So they have a different approach, which is they try to have a model that is really, well, it's from the States as well. So you can understand why non-toxic, safe, not harmful, and helpful output for users. 130 billion parameter, but it's really good. Claude is pretty good in order to generate some code, for example. If you want to generate software development code, Claude is much better than GPT that will try to be creative. And even if the API documentation, for example, does not have any endpoint for this, well, it will try to say, hey, you can use Zendesk API, for example, to integrate this and this when you check documentation, but does not exist. Stick with the reality. Okay, sorry. If you use Claude or Bard, for example, it will stick more with the reality and be less creative. Yes. Yeah, it's the definition they have on the LLM. I'm not quite sure on what does it mean, but they try to be, to do not allow to have toxic information. So like the LLM will be protected in order to not allow to inject toxic information into the model. It's more about ethic point of view than GPT, for example, has not been trained in order to be non-toxic. So Claude has been trained to be non-toxic. So now that we know this, real world use case with a chatbot. If you just use an LLM like it is, what does it give? Well, general information chatbots. A chatbot providing general information to user based on pre-trained language model knowledge, like ChatGPT. That's the first use case in the world and the first use case in this presentation. And we have much more. Now let's jump into the multimodal. Multimodal, text, image, and beyond. What does it mean, multimodal? I'm pretty sure you saw some posts like, hey, multimodal, people are talking about multimodal. I know what does it mean, and it's not complicated, you will see. Look at this phone. More or less, it is like it is. Multimodal is like multiple brands in one channel, like application in one phone, more or less. So, first, multiple inputs. Seamless interplay between text, images, and audio. So imagine that you have one channel where you can, like GPT, they just released, OpenAI, they just released some weeks ago. They are rolling out in Europe. Now you will have in OpenAI, in ChatGPT, you have the possibility without switching between the beta features. So to use DALL-E, to use code interpreter, and to use different model, different LLM to the same channel. You don't need to switch context every time. You use everything the same. That's multimodal. That's all. It's just one application that gives access to all the models, and then you can switch. You can switch between all the models without having to switching the context and then to repeat again the context again and again. But it's also good in order to task-specific excellence. So each model excels in specific task. If you merge all of them in one channel, then multimodal combines many in one channel. That's for this. And also in terms of parameter power. So more parameters. So you have multiple, more LLMs, more parameters, better learning, handling, like a supercharged brain. So you have multi-brain in one single channel, like one phone with all the application. And let's say, for example, that you use, I don't know, you can have one prompt that will access to all the information and try all the application and let you use the content of every, for example, putting one post in Facebook, in Instagram, in Twitter at the same time and push, and boom, that will be a multimodal application. It's not that complicated. One use case example I did, and you can try it, it works, trust me. If you go to OpenAI, you go, for example, to ChatGPT and you choose DALL-E. You navigate to ChatGPT and DALL-E interface, input prompt, you say, hey, make a sprite sheet of 16 frames of a robot dancing, and then save the generate image locally after. Then you save the image, you go now to ChatGPT Advanced Data Analysis, you upload the file, and then you say, okay, slice now this sprite sheet into frames 6x4 and animate into GIFs. You can do it, it will give exactly this. Exactly. You can do it with a cat dancing or whatever you want. So it just, multimodal will help you to do all of this in just one prompt, do this, and that's all. I had to do this with one, to save it, to go to another one, and then to do it, and then, yeah. It was just, if you want to do some GIF and send to Slack to your team, yes. It's useless, but it's fun. So with multimodal AI, you could create animate robot dancing in one single prompt without switching between different models. But what does it mean now in the real world use case with a chatbot? Let's continue with the chatbot. A virtual shopping assistant chatbot. That's what multimodal can give. Meaning that a chatbot powered by multimodal LLM to process both text, image inputs, assisting users in finding outfits that match their preferences and the style of a given pair of shoes. So if you can picture it, so that's what multimodal can bring in a chatbot. So is this experience in an e-commerce website where you can give a virtual shopping assistant chatbot with a multimodal approach. This is exactly what you can do. So you see from one single LLM to multiple LLM in one single channel, you have a full different use case of chatbot that you can integrate. Not the same at all. Now, that's fine tuning, tailored intelligence. So what does it mean? What is fine tuning? Model adjustments. So we saw that the LLMs they have knowledge, they have been trained, but you want to specialize a little bit. I know you want maybe for your company, for your customer success team, you want to introduce all the knowledge database, or you want specific knowledge you want to specify. So you want to adjust the LLM existing knowledge by adding more knowledge or to specialize the brain. And you want also learning from new data. So data that was not in the LLM, you want to introduce this new data. So this is about fine-tuning. Like giving the model a mini course on a new subject. So just training the model. And also in terms of parameter tweaking, meaning that adjusting the LLM parameters to better fit with a specific task. So this is why fine-tuning, what is fine-tuning? And why? What do you want? When do we want to fine-tune the model? Because it's not always, it's costly. So when do we want to do this? Well, first, because of the LLM as a limited context window. If you use OpenAI, depending on the model, you need to stick with the 8,000 token, 16,000, what does it mean? 16,000 of token, more or less one HTML page. They extended this to 120,000 of token. What does it mean? One book. But what if you need more than a book, more than an HTML page into this brain? Well, you need to fine tune. You cannot just, there is other technique we are going to see after, but you can fine tune it. So depending on the size of the information you want to add, then fine-tuning can be a good opportunity. Also for faster inference, because it helps the LLM to answer quickly. If you put the knowledge in the brain, well, you have a new knowledge. If you just put into the context window, and even with 125,000 of token, that's OpenAI there, is great. But if you put book, it's going to think like a brain. So meaning the LLM is going to remember the beginning of the book, the end of the book, in the middle, not everything. I mean, like us. You can ask me some movies I saw in my life. Sometimes I'm watching again the same movie. I don't remember this movie. And at some point, I do remember the end. Yeah. Also, if you want to be closer to domain expertise, if you want to be closer to your expertise, then you want to guide the LLM, like training a cook to become a pastry chef. So OpenAI by default and ChatGPT might not be the best for this, but if you really to specify to be a coach or to be, I don't know, a sales coach, to be a customer success chatbot in hospitality industry, which what I did as well. So you need to fine tune at some point, because when you start to have a lot of knowledge, the balance, just for you to know, if you more than 1 million of tokens that you want to be persistent into the brain, into the LLM, it's better to fine tune it. Less, roughly, there is other techniques we are going to go through. But also, as I said, cost consideration. Fine-tuning, even if you can do it through OpenAI, through the API, depending on how much information you're going to put, is going to cost. So if you add one book, it's going to cost roughly, depending on the size of the book, between $15 and $150 every time you fine-tune. So it's quite not that cheap to add the book as a new knowledge into the LLM. So what is the real world use case still with the chatbot? If you fine tune the chatbot, what can we have? We can have a specialized technical support chatbot, for example. And yes, so a chatbot fine tuned to provide technical support and solution to user facing issues with specific products or services. That's quite a common use case that we can do with a fine tuned model. Now, let's jump into another technique, RAG. What does it mean? Retrieval, augmented generation. So it's about finding answers that make sense. But what is it? It's grabbing and using information. So the R for retrieval is about finding needed information from a big collection. For example, looking up about the French capital. So let's imagine that you want to look up at this. So it's asking a question. So find something. So that's the retrieval. The augmented is using found information to improve the answer quality. So using the capital info to the answer. So it's like sending a query. You have the query, you have the answer, and then you augment, you are going to augment the generation by just with the question, adding the answer and generating one answer. Generation is a part of finally creating a final answer using the information. Example answering, well, the capital of France is Paris. First, there's the question, Second, we are going to find information matching database. We are going to see after vector database or whatever. You can do with Elasticsearch cluster. It works quite well. You need to jump into Pinecone, for example, for one of the most known. You can use only Elasticsearch cluster. It will work the same. So it's asking question, finding some matches into the database or in memory if you don't have that many information, mixing everything, and then answering the capital of France is Paris. So that's all. That's about this RAG. It's just this retrieval augmented generation. So why should we use RAG? Well, better answer, lowest cost. We saw that fine tuning can be helpful, can be faster, but RAG is much cheaper. If you need to deal with the cost, because as I told you, so adding 1 book, 10 books, a lot of information is going to cost. I mean, if it's going to cut your ARPA for your customers and the gross margin, and then the CFO is going after you, hey, as a VP engineering, CTO, or whatever, say, hey, what you are doing with your AI is pretty good, it's nice, it's fun, but now we just dropped from 85% of gross margin to 65%. Okay, I need to find another solution. Well, maybe RAG is a good one. So why? First, because of the broader knowledge. So it provides more accurate and comprehensive answers. Second, better answers as well. So more information helps RAG to provide detailed and accurate answers to questions, which the fine tuning will not necessarily serve the same need. And the last, not the least, which is about cost efficient. If cost is an issue for you, you should take a look on using RAG and extending the window context by going for a retrieval augmented generation. So RAG is a cheaper way to improve answers compared to fine-tuning models. But it serves really different needs. In the real world use case with the chatbot, this is a different use case. It will give you a different chatbot. Which kind of chatbot? Well, a knowledge-enriched customer service chatbot. That's really good for this. Really good for this. Means a chatbot using RAG to fetch, for example, relevant information from a company's database to provide well-informed response to customer queries. Customer success. In Amenitiz, what I did, we have 1,500 articles in the knowledge base in Zendesk. I put all the information in one database. I plugged one LLM. I use a RAG technique. They have a chatbot. When the customer is sending a query, then into Zendesk, they have one embedded application. They put all the context information, and then it's giving the answer that they should send back to the customer. That's good for this. Yep. What about now vector embeddings? So RAG is a structure. It's a technique. It's just a structure. But at some point, you need to persist. And when it comes to persistence, this is where vector embeddings is useful. Yeah, it's this. So what are vector embeddings? The structure for RAG is a numeric transformation. So think about the words or items turned into numbers, vectors, for easier handling by machines. Same word will have the same correspondence in terms of number. And then it will be saved like this somewhere. Super. But what else? The spatial positioning. So places similar items close in the numeral space, making comparison straightforward. And so this is all the beauty of using a RAG technique. Without vector embeddings, you are just having a structure without persistence. You will be limited at some point with the context window. And so if you want to add more and more information, well, you will need to persist this, and you will need to go through vector embeddings. Relationship encoding. So it captures relation like how king relates, for example, to queen, similarities, or a man to woman. So this is what vector embedding is doing. I don't know if you used by the past, long time ago, when I was doing machine learning with Levenstein and comparison between distance, for example, and how words can be identical, similarity with Jarrow-Winkler algorithm, which are good in terms of comparing some names, some address, all this kind of stuff. Well, vector embeddings is really good for this. You can just split by chunks, so by small parts. You save it in one database. whatever, and then you transform this into vector embeddings. OpenAI has one endpoint in the API in order to generate embeddings. You send the text, it will send back the embeddings, you save it, and after you use your Elastic cluster, you ask a question, and boom, you have the answer, more or less. Yes?
It goes beyond word embedding. I know that as word embedding, not vector. Vector word embedding, but can you embed something that's not a word? Like, I don't know, I'm thinking about Valley or something.
At least, I think at least, yes, at least as you can extract the information and you can relate it to what you want to use or to display. It's just a technique to structure and to persist. At the end, it's just a way to persist. And when you ask a question or when you want to match something, a way to match by similarity in spatial positioning with numerics values. So yes. So why? Why using vector embeddings? Well, because it's the efficiency for RAG. Every company is running after efficiency, and every architecture is running after efficiency. If you use RAG, you need to go for efficiency at some point. So that's the persistence and the efficiency of this technique. First, because of the foundational database. It provides a structured numeric database for RAG, enabling efficient data retrieval. Second, because of quick information access. So it helps RAG in quickly finding and fetching relevant information from the database. And third, because enhanced RAG performance. So it's a boost of RAG ability to generate prices and well-informed response quickly. So you can go through the technique and using RAG, and at some point, if you want efficiency, you will need to persist this and to transform into database with the vector embeddings. That's all. Those are two different things and they are complementary. So what about a real world use case with a chatbot? Semantic similarity chatbot or e-commerce product chatbot. Let's imagine, for example, so chatbots utilizing vector embeddings to understand user queries, semantic. Think about that in Amazon. I'm pretty sure that soon we'll have this facilitating a better product recommendation or comparison because you search something. So behind this, that can be used also, for example, in terms of ads in marketing. If you want to provide a better ads, for example, for Criteo, I'm pretty sure they are investigating to this as well. But that's exactly the kind of technique and the kind of structure and persistence that can give this kind of result. So it's semantic similarity chatbots, e-commerce product chatbots. That's the perfect use case for this technique. So you saw all along this presentation, I mean, AI and large language model can be used in different ways. Depends on what you want to achieve. What do you want to achieve for your customers? What do you want to achieve for your company? And what is the cost that you can include into this? So there is a lot of tools in the market that you can find, and depending on how they have been implemented, they are going to give you a different experience. So depending if you want to be productive as an employee, I'm using Bard, I'm using ChatGPT every single day for almost everything in my day-to-day. When I want to have an impact in the product for the customers, I'm trying to investigate, okay, what do we need to achieve? What is the experience we want to bring to the customers? Is it more related on directly having a chatbot plug on ChatGPT, but then the context window will be limited? Do I want to fine tune, but then the cost will be an issue? So depending of the ARPA, depending of the amount of money that the customers are paying the company for the subscription every single month, might not be useful to fine tune it. Do I have the engineering team that can build this RAG technique and persist it with a vector embedding database? Then I can go through this expertise and this experience. All of them can be complementary, but will deliver really something different to the customers. I hope that with all this presentation, so you understand a little bit more. So the LLM, the parameters, the creativity, why it matters, the size when you see, oh, these billions of parameters. Yeah, the more parameters, the more creative. And also when you see all these articles about, oh, there is a new multimodal AI application or framework that allow me to do this. Yeah, wonderful. So what is going to give to me? The possibility to use different LLM in the same place, in the same channel. When I see, for example, I don't know if you heard about Microsoft AutoGen, which is even another usage, which is multiple agents. Think about that now. We have multiple LLMs, multiple chatbots, and the possibility to have all of these chatbots, all the chatbots that we just saw in the same place, communicating with the customers. That's the mission and the purpose of Microsoft AutoGen. When they said, now you will have this architecture where you will have multiple chatbots with multiple LLMs, multimodal, multi-channel, in multi-agent, in one single channel phase for the customer, that's the promise they gave with Microsoft AutoGen. So you see things are moving super fast and there is a lot of opportunities in the market, a lot of tools, but really be cautious on what do you use and if it's really what do you want to bring to your customers. Thanks. I hope it was useful. Any question? Maybe you want pizza? You want a pizza?
How is rack cost efficient? Because your company is way larger than because you have to add all those context.
In terms of cost efficiency, you mean?
Yeah. You were saying it's a low cost solution. I don't think
it depends. It's low cost. It's a low cost comparing to fine tuning. It's not low cost forever.
They do rack. You have to add all the context to all the queries. That's going to increase your cost a lot. And if you have fine tuning.
Yes, it depends. It depends if you want to. If you use OpenAI, you pay per query and you pay per token. If you use RAG is semantic search first, meaning that think about that you have an Elasticsearch cluster and you just want to make some queries semantic because you have, I don't know if you know, like let's say a Google search or whatever, a search in one product and you want to search about products and you just do some searches. So you just need the RAG technique in order to make these vector embeddings at the beginning, but after is going to be the Elasticsearch that is going to be the similarity in order to bring the answer. So meaning that the only time that you are going to use AI for the cost with OpenAI, if you use OpenAI, for example, will be on generation of vector embeddings, more or less. So the cost is really limited into this, and after is in infrastructure. So you pay your infrastructure, but you don't have to pay OpenAI every time that you threw a query to OpenAI. So but it depends really on if you have millions of requests, yeah, maybe it's not worthy to do RAG, and maybe it's not worthy to use OpenAI, and maybe you need to fine tune your LLM. But fine tuning the LLM also is not giving the same experience. You are not going to use an LLM to do a search for a product, for example. I mean, you can, but you are going to chat with the LLM. You are going to ask some question in order to have you are going to use a long context in terms of query, in terms of response. RAG is more short queries, short answer, and after, if you want to go through, they are complementaries. They are not one against another. It depends really on what do you need when you start. And the more you grow, and maybe after RAG, maybe you need to do fine tuning, or maybe you need all of this because you need a chatbot with a fine-tuned LLM to be more specialized. RAG is not specializing; it's more adding knowledge in order to search, and then with a semantic search to collect some answers.
Yeah, I mean, I did a rack implementation. They increased the cost significantly.
Yeah, everything.
Fine-tuned at that point, so I was like figuring out the
It depends how frequently you need to do it. I would say, and depending of.
Right.
Yes, fine tuning is taking time. If you need to fine tune one book, it will take some minutes in order to fine tune it. So it depends what is the experience that you have. If you want to do something more faster, you can use RAG. So it depends really on what you want to achieve at the end. You can use all of this, but it's really, to me, those are different purposes. And that's why I wanted to use different real case world with the chatbot, because you can see that the chatbot that you can build, and so the product that you can build with the different techniques is a full different experience.
Yeah, the real time data.
Yes. Yeah, agreed.
Yeah, I just wanted to add that. In my experience, I would say that fine tuning pays off specialized on technical. So, for example, GPT is not very good at, let's say, legal terms or medical terms for specific languages.
Yeah.
So that's when like you're going to. I agree with that. The use case position.
Yeah, pretty different. For the RAG, for example, I know you know one company that is Algolia. So Algolia, what they created 15 years ago, is what everyone is using now as RAG. They created something really similar to this, but they had, so the competitive mode of Algolia is that they did 15 years ago. And now, well, everyone have it, but the time to build all of this and then to compete with Algolia, well, they can still be the leader in the market. But the technique that they have behind is this semantic search. When you use this API that you can plug in your search engine with Algolia, and then it's giving all the answer that you want in some millisecond or some microsecond, depending of the knowledge that you put in database. That's what they built, and so RAG is really good for this. And that's the strength to me of Algolia, is that they did this 15 years ago. So just my purpose and what I'm saying is that with all of this, try to think ahead on what you can build for your product, for your company, that you can do now, that can help you to build this competitive advantage in your company, that you can be ahead in terms of innovation and using the right technique. I think it's really useful. And the cost, yes, is part of it, but if it can help you to build this competitive advantage for your market, for your company, well, it's worth it. After it's done to you as a engineering leader, or I don't know your position, but to go with a good monetization strategies, yeah, that's worth it to do this, because this is going to give us a competitive advantage in the market. Yes?
How do you test the how do you
Yeah, that's the tricky part. Yeah, you need to test. For now, I'm testing this with internally with the customer service, with people mainly, because it's super hard to understand if the information that you want to have, only human are able to say if it's valuable, not valuable. For example, if you put it in a chatbot, the best way I would say, as a hack, the best way to have it is just to, every time you have an answer, say, hey, are you happy with this? Not happy with this. And based on this, you try to report and try to use it. I was discussing with the founder of DevGPT, for example, the way they value the output they put in the Jira task, in the pull request. It's one extra field where my engineers are putting some comments on why this code that has been generated is not good enough for us. And then the LLM is going to take it in consideration, fine tune. They run it 10 times per month on 110 files in some repositories. And based on the comments, they are going to improve it. So right now, it's still human saying if it's good or not good.
when you said that you are taking a concept from now, how are you doing it with the completely more exclusively RAG analysis without functioning? Because with RAG, all you can do is just augment the quantity.
Yeah, that's it.
So how do you take the concept from RAG without trying to do more?
It's more for the fine tuning than for the RAG. For the RAG, it's like a search engine. If the answer is not, means like when you search in Google and you see, oh, the query was not the good one.
So then your customer service is the concept from now, you're actually using fine tune the model.
Yes. The RAG is more like a search engine. When you search in Google and you put some keywords, depending on how you put them, the answer that you have from Google are not necessarily the one that you want. And so you have some techniques even in the search engine Google that say, hey, I need this plus this. I put this in quotes. And so you force most of the time, the query is not the answer that is not the good one. It's the query that is not well formatted. And so you need to understand why this query has not been well formatted and how you can influence the user in order to put the query that can give you the right answer. I would go more for this, on this way. Yes? More question?
I have one question. Regarding your, so you're saying you mainly like OpenAI models. Like, what about open source models? That you have any, experience on it?
I tried to fine tune Llama 2 model, 7 billion. But the truth is that, well, you need to access to machine with GPU. You need to use AWS. I'm using AWS in my case. So AWS SageMaker, and then it's adding a lot of complexity. Of course, you can do it. You need to test it. You go to Hugging Face, you find the data set, you find a lot of things you can try locally. You go to Google Notebook, you try to, again and again, but it's adding a lot of complexity. I'm a huge fan of simplicity. So that's why my presentation was about this, because I'm a huge fan of simplicity. If you need to do complex stuff, and some companies they need, they go for it. I'm not sure that right now and nowadays there is a lot of companies in the world or in Barcelona that we need to go for complexity. You can do it for fun. I don't see right now a lot of use cases, at least in my industry, travel industry. I don't see a lot of use cases to go and to fine tune a Llama 2 7 billion rather than just, especially after this week, when GPT, they are going to release fine tuning with GPT-4. There is a context window on 128,000 of token. That's simple enough to me. When I will have one cost preoccupation, maybe I can go through a Llama 2 7 billion and with a SageMaker AWS architecture and try to go further into fine tuning with my own engineering resources rather than externalize to OpenAI and pay them for this, because they reduced by 3 times the cost this week. So
I guess it will depend also on how I think Peña improve their platform. They have an inference endpoint or they will provide, I agree with you, but they will provide the service OpenAI offers.
there will be more competition in the future. There is some prediction that on the next 10 years, AI will be divided by 10x. Almost every year will be, and we saw with OpenAI, they just released one new model that is 4 times faster and 3 times cheaper. And so it's just the beginning. If someone is doing it, they are going, and then Anthropic is doing it to do it. Google, Apple is working on this. Everyone is going to do the same. So at the end, I don't know how they are going to do this without losing money, because GPU are still costing. But I mean, I'm for in. If they reduce the cost and increase the speed, even better for us.
Sorry, that's one more question. You said that you're using OpenAI for how do you handle, the data laws and policies around GDPR and PCI introduction environment? Because these APIs did not let you select where your data centers are and what kind of.
Yeah.
So one thing is creating a chatbot using artifacts for fun, and the second thing is virtualizing for a critical time workflow. So how do you address all these legal aspects?
Yes, there is with the enterprise version of OpenAI, which is GDPR compliance. Depends on which version do you use, because there is, I don't know if you use in a company the enterprise and not the enterprise. The enterprise is GDPR compliant, and they don't use it for the purpose of the training of the LLM. So if you use OpenAI with enterprise, already it's GDPR compliant. After, depending on what you send, I will not send sensitive data through the OpenAI. For example, we built in Amenitiz one website builder that is generating a full website for our customers with artificial intelligence. Then you put the prompt, the customer, they put the prompt, they want this delightful experience for the guests when they come to the website, boom, you generate a website, they love it or they change it, but we don't send sensitive data. I mean, there is no IP, there is no full name, last name, email, phone number, or thing that can break the GDPR compliance. So after, I don't see any interest, for example, to send in the LLM to fine tune with information that wouldn't be GDPR compliant. But maybe you have a use case where this is.
Has sensitive information about that.
Yeah.
And you cannot be dragged down and how do you handle that?
Yeah, this is why when you use RAG, for example, and you use only vector embedding database, you don't send sensitive information. You can do the vector embedding without using the OpenAI API, for example. You don't need to use only vector embeddings from OpenAI.
It's just OpenAI.
Yeah. Yes.
Yeah. In one of your slides, you said one of the applications for AI, for example, is like reducing human bias.
Yes.
But at the same time, we know that depending on the training data that you use, you have bias like embedded on the data, and then at the same time, as we're talking about, that like the current versions of models that we have, a percentage of times, or depending on the queries that you ask, want to come up with an answer that is what we call hallucinating. Right? So understanding these current limitations of these models that are available, how would you say that are like the best kinds of applications that we can make of these models today, and what kind of applications would not be the best uses right now?
Yeah.
It would be in the future, but right now it's still not useful or they can take it.
Yes, to me, and it's just my opinion on this, clinical decision is the best use case because right now, well, human doctors are human and are BIs. So if you ask to LLM to do some clinical analysis and to take some clinical decision, that wouldn't be BIs by, oh, I don't want to do this because now I know you. Now I know you. So I'm going to take a decision based on my BIs that now I know all of you in this room. And if I am a doctor, I might not take the same decision that if I don't know you. I think that's, and in 2024, I think that will be the first company that is going to create one LLM specialized in the vertical of medical and clinical decision would be, that would be the best use case to me on using LLM without getting BIs. That's the perfect match what I see by using LLM, because else, yes, everything that you use with ChatGPT, you tend to give another question to the ChatGPT because you are biased and you want the tool to answer as you want. And I do it because I'm biased, so I want you to do this because maybe it's not what you need, but you are pushing and trying to force in order to, no, but I really want to do this for me. Do it for me. And at some point, because it's creative, it's going to do it. But in this area, I think on the medical and clinical decision, I think that might be the best use case because this is not going to get BIs at all.